The official numbers didn't make sense. The force calculations, the trajectory residuals, even the observed coma, all pointed to one unbelievable conclusion. The non-gravitational acceleration of the object, known as 3I Atlas, was less than 15 meters per day squared. That's incredibly small. For the amount of gas seen spewing from it, only a body of immense mass could resist being nudged off its path. And the numbers all converged on a nucleus at least several kilometers wide, with a total mass exceeding 30 billion tons. This result held up under every test analysts could think of. Monte Carlo runs, density tweaks, even alternative force models. Each time, that lower limit stayed stubbornly high. For the very first time, the interstellar comet catalog had a true heavyweight contender. When the final mass figures circulated, shockwaves hit the research community. In the world of interstellar objects, size is everything. And Atlas didn't just break the curve, it shattered it. For context, every other interstellar object we've ever seen, like Oumuamua and Moisov, were cosmic pebbles by comparison. Atlas, at over 30 billion tons, stood completely alone. Prevailing models, built on years of sky surveys, predicted that a massive, active interstellar object like this should be vanishingly rare. So rare, in fact, some theorists argued we might never see one in our lifetime. Within hours, the crisis spilled beyond a single working group. Emergency teleconferences brought in teams from NASA and the European Space Agency. The numbers were double-checked, then triple-checked. Yet the mass held firm, no matter who ran the data. The odds of finding a kilometer-scale outgassing interstellar object were orders of magnitude lower than finding a small visitor like Oumuamua. The tension was obvious. Some called it the most improbable find in decades. By the end of the week, the consensus was clear. This object was anything but ordinary. The debate around Atlas's true nature now plays out across a spectrum. At the foundation is the consensus view from NASA and most planetary scientists. Atlas is a massive natural interstellar comet. Its features fit, even if they stretch the boundaries of comet science. But a layer of plausible, yet unusual, features fuels deeper curiosity. For one, its orbit is nearly aligned with the plane of our own solar system, a statistical oddity for an interstellar visitor. Its path also threads a cosmic needle, bringing it close to Mars before heading toward Jupiter. And then, at the speculative end, some researchers have floated a more radical idea. The argument hinges on that huge mass-to-acceleration mismatch and its peculiar orbit. As one prominent scientist put it, if Atlas is truly a billion-ton object defying our models, we must be open to possibilities outside the norm.